In this video, we examine yet another case of logarithmic differentiation. In this case, we're given the function x raised to the power sine x. We set the function equal to the variable y, and we take the natural log of both sides. And then we use the rule of logs to put the sine of x that's in the exponent down so that we have the expression sine of x times ln x equals ln y, and then we take the derivative of both sides. So for the left hand side, we have the derivative of ln y, which is 1 over y, but since y is composed of a function of x, we must multiply by the derivative of y with respect to x, which in this case, well, we don't know exactly what that is, so we just leave it in terms of the general form here, and we set that equal to the right hand side, which for the right hand side we apply the product rule. So we have the derivative of sine, which is cosine of x times ln of x, plus sine of x times the derivative of ln of x, which is 1 over x. And we multiply both sides by y, and since we know that y is equal to x raised to the power of sine x, we can just make that substitution and we arrive at our final answer, and we have the desired expression for the derivative. So anytime we have the form where we have a variable raised to some function up here, well, we set that expression equal to y and perform the following series of calculations. And when we follow through with the left hand side, it will always equal this expression just as it did in the example. So you can just go ahead and start with this function on the left hand side, and it'll be useful in terms of that calculation.